So hey there, everyone. I'm Auryn MacMillan from Gnosis. Today, we're going to be diving into the conditional tokens framework, some of its current and potential applications. At a really high level, conditional tokens are tokenized logic. If this, then that, with the value of each token depends on the outcome of some event, as reported by an oracle. These tokens can be combined to form new tokens whose values is contingent on arbitrarily complex logic. If A and B or C, then dollars, else poop. One obvious use case for conditional tokens is prediction markets like Auryn and Poly market. This is the application that the conditional tokens framework was kind of designed to support. In this case, each outcome or collection of outcomes corresponds to a position in a prediction market. The recent US election markets are a great example of this in action in the wild. Collectively, Auryn and Poly markets saw millions of dollars in trading volume on their conditional token-based markets covering the US election events. But as a primitive, the conditional tokens framework or conditional tokens enable so much more than just prediction markets. Here's a quick TLDR on how they work. Essentially, you create a condition, usually in the form of a question like, will X happen? And then deposit some collateral. For each unit of collateral, you get one conditional token or position corresponding to each outcome or collection of outcomes. So in this case, we're taking a unit of collateral and splitting it into a yes and a no token for that condition. At some future date, an oracle resolves the condition, then anyone holding the conditional tokens or the corresponding conditional tokens can redeem them for the underlying collateral. It's worth noting that conditions are resolved with a payout vector that defines the ratio of collateral that each outcome should be redeemable for. So in the case on screen, we're presumably paying out 1 to 0. So one conditional token gets all of the collateral, the other one gets none. But it could just as easily be a 60-40 split or any other ratio that adds up to 1, for example. To build more complex logic, we can create combinations of conditions that result in positions dependent on the outcome of 2 or more lower level conditions. This is a unique feature of the conditional tokens framework and is one place where things get really interesting. This allows you to do things like escrow, trustless milestone-based payments, where milestone 2 can only be paid out if milestone 1 has been completed, crowdfunding, where the project only receives the fund if more than X amount of funds are raised by more than Y amount of people, insurance, payments that trigger when a smart contract is exploited, as reported by some oracle, options contracts, where users buy or sell an asset if it reaches a certain price threshold by a particular date, token vesting based on time and or performance, and futarchy, where governance decisions are made based on their predicted impact. The piece of the puzzle that adds most of this flavor is the oracle contract, or the oracle, not necessarily a contract, but the oracle address. So the conditional tokens framework is oracle agnostic. Any address that can interact with the conditional tokens contracts interface can act as an oracle. And it's the oracle that then decides when, how, and why a condition is resolved. In some cases, it may make sense for a trusted individual or a multi-sig to be the oracle. In other cases, you may want to implement some logic around the resolution, in which case you could write a contract or use an existing contract for your oracle. In the wild, we've seen EOAs and multi-sigs used to resolve conditions, but by far the largest number of conditions that have been resolved are resolved using reality.eth as the oracle with Claros as an arbitrator. And I say the largest number of conditions because this is what the prediction market Auryn uses. For the rest of this talk, I'll dive into some of the use cases that I mentioned earlier and muse about what an oracle might look like for those use cases. This is intended to serve as, I guess, inspiration for something that you might want to build a product or service around. Feel free to jump in and chat at any point with questions, and I'm happy to kind of pause and dive down rabbit holes. And then at the end, I think we'll have enough time for some additional questions. I'm happy for people to jump in on camera if they want, or just drop things in chat. Sol, I see you just asked a question. Are these tokens effectively NFTs, or are they fungible? So you're dropping collateral in, say DAI, an ERC20 token in, and splitting it into an equal number of conditional tokens. So say your condition has 2 outcomes, yes and no, then you drop 100 DAI in, you'll get 100 yes tokens and 100 no tokens. Those 100 yes tokens are all fungible with one another. Those 100 no tokens are all fungible with one another, and they are just as divisible as the ERC20 token that you put in. It uses the ERC 1155 standard to essentially save on gas, make these much more efficient. But we do have a wrapper contract, so you can wrap those tokens into an ERC20 if you want to interact with them, say in Uniswap's automatic market maker contracts, or otherwise plug them into other systems that aren't designed to run with the ERC 1155 token standard. So we'll jump in. Escrow is the first kind of really basic example here. Alice wants to transact, or Alice and Bob want to transact. Maybe they're swapping tokens. Maybe Bob is doing some work for Alice. Or maybe Alice and Bob are collectively paying someone else for something. But there are no chargebacks in crypto. Neither Alice nor Bob wants to be the first to send their tokens. Traditionally, you'd have some trusted third party hold onto assets and transfer the tokens or transfer the value to the respective parties once the agreement's been executed. But that requires trusting a third party. Instead, Alice and Bob can create conditional tokens that are valuable only if their counterparties execute the agreement. For example, let's say Alice is paying Bob for some work. Alice would split their conditional tokens, split their collateral into 2 conditional tokens. One for yes, Bob did the work, and one for no, Bob did not do the work. They would send Bob the yes tokens, and they would keep the no tokens. The oracle they use could be a contract where either Alice or Bob could propose a resolution, a payout ratio. The other can then accept the proposal, create a new proposal, or request arbitration from a third party that they previously agreed on. So Bob finishes the work, calls the function to resolve the contract, and then lets Alice know. Alice is happy with Bob's work, so they call the function to accept the proposed payout. Bob redeems their tokens for the underlying collateral, so Bob gets paid. And in this way, no third party ever takes custody of the tokens. And at least in the happy path, no third party is involved in resolving the condition. PrimeDAO recently wrote a really awesome blog post about how this could be used as a communication medium between DAOs to facilitate DAO-to-DAO asset swaps, commerce, and joint ventures. And so we see this as a really interesting kind of way of creating these agentless escrows, or at least these much less trustful escrows. An extension of that is crowdfunding. So crowdfunding is essentially a multi-party escrow. Someone wants to do something but needs a minimum amount of capital and maybe participants to commit to the cause before it can happen. So Kickstarter and the ETH2 deposit contract are 2 great examples of this concept being used in the wild. The former is entirely trustful. All of your funds get sent to Kickstarter, and they hold them until you hit this critical threshold, until the campaign's over, and then they hand them off to the fundee or the recipient. And then the latter is very purpose specific. It's not something that you could kind of apply easily to another condition. The conditional tokens framework enables a much more general purpose version of crowdfunding that is as trustful as the oracle that you use. So assuming you go and pick an oracle, say like the Auryn oracle, you could create a very trustless crowdfunding campaign. So let's say we have a protocol with an ERC20 token, and we want to kick off staking rewards only after it's reached some minimum threshold of deposits in that token. We want this to be permissionless and trustless. So we create a deposit contract then we set up a condition to the effect of, will the deposit address have more than X yes tokens deposited by some future deadline? Yes or no? Contributors split their collateral into yes and no tokens. They send their yes tokens to the deposit contract and they keep their no tokens. The oracle for the condition, for a condition like this, could be a contract with a public function that requires the block height to be greater than some number, whatever the deadline end is. And then if the balance of the deposit contract is higher than the threshold, it resolves to yes, and the deposit contract redeems the collateral. Otherwise, it resolves to no, and the backers can all redeem their collateral back. If we wanted to crowd something that's not queryable on chain, say to raise funds to reward development of some public good software, we could use a similar oracle to Omen, like I mentioned earlier, so reality.eth and Kleros. In this case, our condition would be something like, did the team build the public good software by some deadline? Once the team sees that enough tokens have been deposited to cover the cost of their work, they start building. Then after the deadline passes, anyone can start the resolution process by picking an outcome and putting a deposit on it. Anyone else can challenge it by doubling the deposit and selecting a different outcome. And this escalation game continues indefinitely until one side gives up or someone calls for arbitration by Kleros. Again, this is a system that's already implemented and being used in Omen. Assuming the team has built the software to a standard that the community accepts and that the escalation game's theory holds true, the condition should resolve to yes and the team gets paid. One really cool outcome of this is that while the team doesn't have access to the underlying collateral, they do have immediate access to the yes conditional tokens. They could pay their team members with these collateralized yes tokens so that team members know precisely how much collateral they'll individually get if they collectively ship the work. I could even imagine an analog to payday loans where some service buys the conditional payment tokens at a discount so that the individuals receiving them as a payment for their work have immediate access to more liquid capital, more liquid assets. But maybe analog payday loans are not the best outcome to be, or an analog for payday loans is not the best outcome for us to be aiming for. So we could look at setting up some milestones in advance so the dev team can get paid more regularly, but only if they hit specific development milestones. This is one place where the logical combinations that I mentioned at the beginning really start to shine. So we can set up a series of milestone payments in advance that are conditional on the previous milestone having been fulfilled. So each contributor to the initial crowdfunding campaign would split all of their collateral into the condition representing milestone 1. Some proportional amount of the yes outcomes from milestone 1 would be split into a condition representing milestone 2. Some proportional amount of the milestone 2 yes outcomes will be split into milestone 3, and so on and so forth. The contributor keeps all of the no tokens and sends all of the resulting yes tokens to the crowdfunding address. As the team completes milestones, they're able to redeem a relative portion of the total crowdfunding pot based on these yes tokens for each of the kind of subsequent conditions. If at any point the team stops shipping, then the backers can get the remainder of their tokens back. For milestone payments, we would probably want an oracle that's a bit more flexible on the resolution date than our existing oracle. This is somewhere that there's a really big opportunity for kind of additional research and additional work just to come up with, again, more less rigid time-based oracles. Let's say we want to set up a token vesting agreement. In this case, we could do something similar to our previous milestones by linking several conditions together in a chain, one for each vesting period, the current being dependent on the previous. The oracle for a vesting schedule might be a contract that checks the current block or a Unix timestamp, along with some bool to determine whether tokens should still be vesting. For each vesting period, if the current timestamp is greater than X and the bool is still true, say if it's an employee, it might be checking whether the employee is still employed, so they should still be vesting. So if the bool is true, the condition can be resolved to yes, and the vested tokens can be redeemed. This has a couple of really interesting qualities to it. The recipient can know upfront that the vesting tokens have actually been allocated. The recipient can choose when to redeem their vested tokens, choosing when to kind of initiate a taxable event. And then prior to vesting, the corresponding outcome tokens can be freely transferred. So unvested tokens could potentially take on some additional utility for recipients. And finally, let's talk about governance. This is the part that, or the kind of use case that most excites me. So most blockchain-based governance uses some variant of naive token-weighted voting. One token equals one vote. Sometimes with some locking or staking mechanics. In theory, token-weighted voting provides good civil resistance and aligns incentives with the value of the token, since those that hold the most tokens have the most influence, but also have the most at stake. In practice, however, it suffers the same pitfalls as any other plutocratic system. The incentives align for the largest token holders to extract value from the smaller token holders. And in some cases, it has some additional issues like vote manipulation from users that have no stake. See the flash loan attacks on MakerDAO's governance, for an example. The root issue of token-weighted voting is that it actually aligns for the preference of whoever controls the critical number of tokens at precisely the right time. And it cannot account for externalities that may make an action profitable to some token holders while being detrimental to the rest. What if we could align for outcomes rather than preferences and better mitigate for those externalities? So let's talk about futarchy, governance by prediction market. I won't go too deeply into futarchy. If you want to learn more, I'd recommend checking out Robin Hanson's 2013 paper, Shall We Vote on Values but Bet on Beliefs, and Vitalik's 2014 blog post, An Introduction to Futarchy. The core idea is that decisions could and probably should be made based on a market's prediction of how they'll impact an organization's key metrics. So say an organization needs to decide on whether or not to fund a project, the outcomes it care about, for example, could be user numbers and token value, is trying to hit some KPI in each. So they create three conditions. Will user numbers be higher than X at some deadline? Will the token value be higher than Y on some deadline? And will the proposal pass? And so rather than making decisions on essentially the preference of the token holders, they make decisions on how the market responds to these questions. If the last condition resolves to yes, the funding is allocated to the project. To reach a decision and resolve that last condition, the organization would analyze the trading activity between two potential combinations of positions. Again, this is where the conditional tokens framework really starts to shine. We're basically building a logical statement out of these various conditional tokens. So we have two positions that we build here. The first is if the proposal passes, user numbers will be higher than X and token value will be higher than Y on the deadline. If the proposal passes, the other position is if the proposal passes, user numbers will not be higher than X or token value will not be higher than Y on the deadline. I'll break script a little bit here and just dive a little further into kind of how we do this if statement. So essentially you need to have a few different markets kind of running in parallel. And you get to this if statement by buying a very specific amount of tokens in the will this proposal pass market. So you would actually buy the opposite position to what you are wanting to, or to the outcome you're looking to kind of create a position in. So it's, I guess, a little counterintuitive there. You would buy enough of, say, the no position in the will this proposal pass market, so that if the proposal does not pass, you get all of your funding back. And so that's why we call it kind of an if condition there. So you're saying you're buying enough of a position there that if it does not happen, you get your funding back and essentially everything reverts. You go back to having the initial amount of collateral that you started with. And then the remaining funding, you buy the yes position, but actually split it into a combination of these other tokens. So you're saying, if this proposal passes and A and B happen, then this is the position that I'm kind of buying. Or conversely, if the proposal passes and not A or not B happen, then this is the position I'm buying. And then we're trading the thing that the organization is interested in is the kind of trading activity between those two potential paths, and looking for, essentially it would pass if the top one on screen here is trading at a higher value than the bottom one on screen there. The oracle for the two metric conditions could be an on-chain price feed like Uniswap for token value, or something more like Auryn's oracle for user numbers. For the futaki condition, will this proposal pass, the Auryn oracle could be used. After the trading period, anyone could analyze the trading activity and attempt to resolve the condition via the escalation game. Another option might be to have an oracle contract that analyzes the on-chain trading activity, a price feed like Uniswaps, and resolve directly from that. In either case, this should create a system where decision-making optimizes for the impact of the decision rather than the preference of stakeholders or the preference of token holders. So the common threads that I hope I've kind of drilled in at this point is that conditional tokens are this kind of unique primitive for building logic-based value. And because the conditional token framework is oracle agnostic, when, why, and how that logic is resolved, like what that logic actually looks like, is entirely up to you. It's entirely programmable. So thanks for tuning into the talk. You can learn more and build on the conditional tokens framework. Check out our Discord server, our forums, and the docs. On our forum, we also have a list of Oracle features that we'd love to see built. If anyone's looking for a challenge, we're happy to pay out grants for kind of working general purpose oracles that implement some of these interesting features. If you have an idea or need some advice and or funding to make something with the conditional tokens framework happen, feel free to get in touch. And yeah, I've got a few minutes left, I think, to answer some questions if we have any. And yeah, otherwise, thanks for tuning in. So I see a question that's come through again from Sol. He said, I may have missed this, but is the conditional condition stored in metadata in the conditional token, or is it available directly on chain? So the condition uses a basically 32 bytes of data as the condition ID. And so how you encode the condition ID is kind of entirely up to you. So that condition ID is available on chain, but you need to know how to decode it, or at least how it's encoded. Oh, great, cool. So also he's doing this on a side project. I'd love to learn more about it. I'll hang out and chat, I guess. If you want to talk more about it, or feel free to hit me up on Twitter or Telegram. We can keep diving into it. I'd definitely love to hear more.